Good morning, students. In the previous class, we have discussed about the refraction at spherical surface. In refraction at spherical surface, we found an equation that was mu2 by p minus mu1 by q is equal to mu2 minus mu1 by r. That was we found yesterday, we found on the previous class, and that is refraction at spherical surface. And what was it? Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. And in this case, what was mu2? Mu2 was the medium where light enters. Remember, mu2 is the medium, mu2 is the refractive index of that particular medium to which light entered. And mu1 is the refractive index of that particular area from where light emitted. And this was image distance, object distance, and this is radius of curvature. Today we will discuss one of the very most important topic for optics class 12 physics for final exam and for higher concept also in case of optics, that is Lense Maker formula. Lense Maker formula, why it is called Lense Maker formula, will come to know later to this video class. But one thing, let me tell you, the Lense Maker formula will be related to strictly this particular equation. We have to understand it. Let's go to the Lense Maker formula today. For that, in order to derive the Lense Maker formula, we need to take a convex lens. Hence, you can say as double convex lens we'll consider. Suppose it is a convex lens, or else you can say it is a double convex lens also. You can say, as you can say that both side is convex. Understand? So if you take this is a convex lens, and this will be the principal axis of it. You are very familiar with this type of diagram. We have drawn it for so many time. And if I consider that refractive index of this medium outside this particular lens is mu1, and inside the lens is mu2, with a condition applied that mu2 will be definitely greater than mu1. Understood, no? Mu2 will be definitely greater than mu1. It is very simple because this is going to be glass medium, and it is hopefully it is air medium. So air medium will be generally rarer in comparison to the glass medium. Understand it? Now, if I take, you can see now here two surfaces. This is one spherical surface. This is one spherical surface which will form a center of curvature somewhere here, C1. And this is one more spherical surface, and this spherical surface will also contain another center of curvature somewhere here, that is C2. You understood what is C1, C2? C1 is the center of curvature for this particular spherical surface. C2 is the center of curvature for this particular spherical surface, as we know that there are two spherical surfaces in the double convex lens. Now I am taking an object here, suppose from here, and light has been incident on it. Let's see what happened there. Understand very carefully. This is the ray of light that has been incident from the object O. Now, once this light ray has been incident from O object, that means it is entering from rarer to denser medium. And what happened when the light of ray travels from rarer to denser medium? Once it travels from rarer to denser medium, after refraction, the refracted ray bends towards the normal. That means we have to make a normal here. Let me tell you, the normal is always drawn from the center of curvature. Am I clear? This is a normal, and normal will be drawn from center of curvature. Remember, normal should be drawn exactly at center of curvature. So this is the normal. This is the normal for fast reflecting surface or fast spherical surface at this point. Am I clear? So after refraction, this ray will now bend. This ray will bend towards the normal. That's good. So simple. Understand? No? This ray is bending towards the normal after refraction. This coming from optically rarer to optically denser medium, and this is normal, and after refraction it is bending towards the normal, and here somewhere it is the image. Remember, this is the image. This is the image for the first spherical surface. This is the object for the first spherical surface. This is the center of curvature for the first spherical surface. This is the normal for the first spherical surface. Am I clear? This is the first thing. That means this is for the first spherical surface. Let us consider the radius of curvature for first spherical surface to be R1. Radius of curvature for the second spherical surface supposed to be R2. But one more surface is available here. There will be also refraction. After completing the phenomena in the first reflecting surface, we'll move to the second reflecting surface gradually. Second spherical surface gradually. So what will happen in case of second spherical surface? Let us see that in case of first spherical surface, light enters from optically rarer to optically denser medium. Now in the second case, light will traveling from optically denser to optically rarer medium as it coming out from the lenses or not. In case of second case, what? The light is coming out from the lens to the air. As it coming from lens to air, that means what? The light is traveling from optically denser to optically rarer medium. So what happened in this case? Once light travels from optically denser to optically rarer medium, that the refracted ray goes away from the normal. So in the second case, I told you, in case of second reflecting surface, this is the center of curvature. So I'll draw the center of normal from the center of curvature. That means like that. That is the center of curvature for the second surface. So I am drawing this normal. Okay, this is the normal right from the C2 center of curvature for the second spherical surface. This is second spherical surface, and this is center of curvature for the second spherical surface, and I have drawn the normal for the second surface. Now interestingly, the image of the first reflecting surface, image of the first spherical surface I will behave as the object for the second spherical surface. Understand? As a virtual object. Okay, this image, that was the I was the image for the first spherical surface I told you. Now in the second spherical surface, this image will behave as the virtual object for the second spherical surface. Now this is the normal for second spherical surface. I is behaving as virtual object for the second spherical surface. So once light travels from optically denser to optically rarer medium, what happens? The ray of light will bend, will go away from the normal. So in the second case, the ray of light will go away from the spherical normal. This is the normal for the second spherical surface, and after refraction, this is the refracted ray for the second spherical surface. Now this ray will go away from the normal. As you can see that this ray is coming away from the normal. That means this is the, suppose it is I dash, and I dash is the image of object I. I dash is the image of object I for second spherical surface. I is the image for the first spherical surface with respect to object O. Understand? I'm again clearing your diagram. You can see this were the normal for the first spherical surface, and after refraction this refracted ray is coming closer to normal. In the second case, this is the normal and this is the refracted ray, and this refracted ray is coming away from the second normal in case of second surface. Why? Because in the second spherical surface, the light is traveling from optically denser to optically rarer medium. Clear? And the image of the first spherical surface will behave as virtual object for the second spherical surface. Is that clear to you? So this is a diagram. You kindly draw it with the appropriate direction. Now we know that refraction at spherical surface. What was it? Refraction at spherical surface was mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. That was the equation or result. That was the result of refraction at spherical surface. Mu2 by v minus mu1 by r is mu1 by u is equal to mu2 minus mu1 by r. And what is this v was? Mu2 means the medium where light enters, and mu1 from where light went. Now for the fast reflecting surface, you can write for the first spherical surface. For the first spherical surface. This was the first spherical surface. In the case of first spherical surface, you need to see from where light is entering. Light is entering from mu1 to mu2. Remember, for the first reflecting surface, light is entering from mu1 to mu2. That means the formula will be stated as mu2 by v minus mu1 by u, because light is entering from mu1 to mu2, is equal to, you can write mu2 minus mu1 by radius of curvature is r1 for the first spherical surface. Have you got it? So this is mu2 minus mu1. Why? Because light has entered from mu1 to mu2. Now in this case, this implies we can write mu2 by v. What is the v in case of first spherical surface? And I have forget to give one thing. This is the optical center C. I have taken optical center C for the convex lens. Understood now? So in this case, if you have considered what is v for the fast reflecting surface, for the fast reflecting surface, v will be, that is image distance ci. Ci is the what? Ci is the image distance for the fast reflecting surface. I will write as ci. Mu2 by ci minus mu1 by u. What is the object distance? Object distance was co. This is co. You can see co is the object distance for the first spherical surface. Ci is the image distance. I have written in the place of v. Co is the object distance. In the place of u I have written. And of course, this object distance will be a negative. As you know, that object distance is always counted as negative, is equal to mu2 minus mu1 by r1. What is this r1? r1 is the center of curvature for the lenses. That is center of curvature for the first spherical surface will be what? C2. That is C1. This is CC1. CC1 will be the center of curvature for the fast spherical surface. So I will write here CC1, and let us suppose this is number 1 equation. Is that clear to you? Okay. Now for the second spherical surface, you can write for the second spherical surface. For the second spherical surface. For the second spherical surface, what happening? For a second spherical surface, one more thing, this is CC1 will not be negative, it is positive because it is right side of the particular spherical surface. Now for a second spherical surface, let us see what happens. In a second spherical surface, the light is traveling from mu2 to mu1, mu2 to mu1. In the first case, it travels from mu1 to mu2. That's why we consider it is what, mu2 minus mu1. But this time, light is traveling from mu2 to mu1, so it will be mu1 minus mu2. That means we will write a formula as, for the second spherical surface, mu1 by v minus mu2 by u is equal to mu1 minus mu2 by r2. What is this r2 is? Your r2 is the radius of curvature for the second spherical surface. You mind these things. mu2 minus mu1, you understand that light is traveling from mu1 to mu2. mu1 minus mu2, you will understand that light is traveling from mu2 to mu1. Understand? So in the second spherical surface, what are the specifications we can see? mu1 by v. This is the second spherical surface. For second spherical surface, the image was ci dash. Ci dash. Is that clear? Ci dash will be the image for the second spherical surface, and minus mu2 by object distance, that is u. Object distance will be in this case positive because it is lying this side, because of the partial object, so it will be what, ci. This is ci, so I'll write as ci. Understand, I told you that the image of the first spherical surface behave as the partial object for the second spherical surface. So for the second spherical surface, object will be ci and image will be ci dash. Understand? Is equal to mu1 minus mu2 by r2. What is this r2? Radius of curvature for the second spherical surface. This is second spherical surface and reflect a radius of curvature cc2, it is left side, minus cc2. This is the specification for the second spherical surface. I think you have got it. Okay, this is number 1 equation, number 2 equation. Now I am going to add them. If I add number 1 equation, number 2 equation, just take a look seriously. This is a very important topic. Don't get confused over it. Just go through it, okay? Now, you write adding 1 and 2. If I add 1 and 2, now 1 plus 2. I am gonna add 1 and 2 now. If you add number 1 equation and number 2 equation, what was number 1 equation? This is number 1 equation, this is number 2 equation. I have taken this side, you see, mu2 by, let's keep watching, mu2 by ci minus, this is minus minus plus, minus minus plus, so I can write this is mu1, mu1 by co plus mu1 by co, again plus this part mu1 by ci dash, mu1 by ci dash minus mu2 by ci minus mu2 by ci is equal to, next side will be what, mu2 minus mu1 by r1, mu2 minus mu1 by r1 plus mu1 minus mu2, mu1 minus mu2, not r1. In the place of r1 you have to write cc1. Is that clear to all of you? And in the place of r2 you will write minus of cc2. So I can write directly, this is if I add them. So since this minus, minus plus minus, not it is okay, this plus minus cc2. Understand? Now mu2 by ci will be cancelled. What will remain here? mu1 by co plus mu1 by ci dash is equal to mu2 by mu1 by cc1, that is plus, if I make one thing for sure here, this is minus cc2 and this is mu1 minus mu2. If I want to make this upper part similar, as it is mu2 minus mu1, so I want to make this is also mu2 minus mu1. So if I convert mu1 minus mu2 to mu2 minus mu1, that means if I adjust this thing, what will happen? If I write this is mu2 minus mu1 and this is going to be plus, because once I bring this is minus mu1 by mu2, it will be like that. So I am adjusting it, you have understood? So if I oppose these things, or if I then turn these things, to be mu2 minus mu1 and this minus will automatically plus. This is implies this is mu1. Mu1, what is CO? You can see as CO, this is your CO. CO is your what? This CO is your object distance. Understand? CO is your object distance. This is object distance CO. So I'll write is object distance U and it is going to be minus. CO is the object distance, in this case I have told you, so it will be going to be your minus. Plus, what is mu1 by ci dash? Ci dash, this ci dash is going to be your image distance P, is equal to mu2 minus mu1 by cc1. This is cc1 is going to be what? Radius of curvature. cc1 is going to be your radius of curvature, and the radius of curvature for the fast reflecting surface. cc1 is the radius of curvature. This is r1 and it is positive itself, plus mu2 minus mu1 cc2, this is cc2, this radius of curvature for the second reflecting surface. This is r2 and it is going to be minus of r2. So if I arrange it now, mu1 by v minus mu1 by u is equal to again mu2 minus mu1 by, that is you can write now this is r1, so this minus mu2 by mu1 minus r2, minus plus minus I have written, this is r minus u. Understand? So in this case I can take here mu1 common, 1 by v minus 1 by u. Okay, if I take here mu2 minus mu1 as common, 1 by r1 minus 1 by r2. So if I write finally 1 by v minus 1 by u is equal to, this will be what? Mu2 minus mu1 by mu1 whole into 1 by r1 minus 1 by r2. So at the end I can write this is 1 by v minus 1 by u. What is 1 by v minus 1 by u is exactly 1 by f from the Lense formula. In place of 1 by v minus 1 by u, we can write 1 by f. 1 by f we can write, it is from Lense formula we know, is equal to what? Mu2 by mu1 minus 1. Mu1 will be cancelled out. So at the end it is 1 by r1 minus 1 by r2. That is the required Lense Maker formula for us, and you should practice it hard. That is a very important formula. In special cases there are some 2-3 points, we'll discuss it in the next class. Until then you keep practicing this diagram. In the next class if you need, you must inbox me. I will again repeat these things if you have any problem. So 1 by f is coming from this Lense formula, since we know that 1 by f is equal to 1 by v minus 1 by u is the Lense formula. And there's also one logic behind it. This is like that. So Lense formula is 1 by f is equal to mu2 by mu1 minus 1 whole into 1 by r minus 1 by r2. I hope you have understood it. I'm again telling this is a very important topic. Please practice it. If you need, I'll repeat the next class again, but you have to cooperate me, inbox me. Thank you so much for today.